Welcome to Spring LIB.
Hello everyone, today we're doing chapter 19, problem 12. This problem asks us to draw a product of each of the following acid-base reactions. So what we have here is some acid. So this is in A, we have a carboxylic acid, and we're reacting that with sodium hydroxide, which is a very strong base. So if I redraw A over here, we can see that we have this carboxylic acid. And then I'm reacting that with sodium hydroxide. Remember, sodium, any metal and organic compound will dissociate fully to the metal being positive and then this base being negative. So we'll have sodium hydroxide fully dissociating in solution. So in essence, what you have is sodium with hydroxide ions. So a hydroxide will act as a strong base and it will act as a proton acceptor, and what it's going to do is it's going to nucleophilically pick up this proton, deprotonating this acid, being a proton donor. And then what you're left with is the conjugate base of the acid being a deprotonated form, so the O minus. But then you have an O minus, and nature likes to have things tend towards neutrality. So in order to neutralize this negative charge, this free sodium ion, which is positively charged, is going to come right next to it and is going to electrostatically interact with this negative charge such that positive negative charge will equal up to being net neutral. So this will essentially neutralize this carboxylate conjugate base, and then because of the OH, the hydroxide picked up a proton, we will also get water being formed. So now in B, this time our acid is going to be this alcohol. And then same thing, we have another base. We have sodium methoxide, sodium, and we have a methoxide. So same thing, methoxide will act as a base, pick up this proton, making a negative charge on this alcohol, in which sodium will go right next to it to make sure it stays neutral and electrostatically interact with it. We have the O minus and sodium right next to it. And then we'll get this methoxide picking up that proton, being fully protonated to methanol. And now in C, what we have is another alcohol, tertiary alcohol. But now we have sodium hydride, so even a stronger base. So sodium hydride is not nucleophilic. It's a very strong base. So once again, hydrogen does not like being negatively charged. It just wants to be neutral. So the only way it can be neutral is if it picks up another hydrogen. So the most acidic hydrogen on this molecule is this alcohol's hydrogen. So we'll pick that up, making hydrogen gas, and in the process of making a tert butoxide anion. The anion will be stabilized by this positively charged sodium in close proximity to it through electrostatic interactions, and then we'll also have this hydrogen gas being produced. And now in the last one, we actually have sodium carbonate reacting with the same acid as in A, or a similar acid as in A. It's a benzene ring this time. And same thing, sodium will fully dissociate with the carbonate to make CO3 minus. And then this HCO3 minus can pick up the proton to form bicarbonate, being H2CO3, neutralizing it, and making negatively charged carboxylate conjugate base, which will be neutralized by the proximity of your positively charged nitrogen, or positively charged sodium, sorry.